just going to start off talking a bit about general ideas, what use is data science and machine learning, what it actually is. And then we'll start off just with some, I guess a Python refresher for people who don't have that much experience. So we won't spend too long on that, but then we'll move on to the actual data science and machine learning stuff. So yeah, to begin with, I thought we could just talk a little bit about what the definition of machine learning actually is. And we can discuss what the difference between AI versus machine learning is. So yeah, does anyone want to go ahead and define machine learning? Oh, that's an open, anyone who.
So it's when you train a machine to kind of make decisions on its own or kind of produce results on its own based on what you fed into it.
Mm-hmm. Yeah, that sounds pretty good to me. So can anyone say what the difference between AI and machine learning is?
I think AI maybe doesn't need the training or the results being fed into it quite so much.
Mm-hmm. Does anyone else have any intuitions or?
I always imagine that they have a hierarchical sort of relationship. One is below the other.
Absolutely. So yeah, that's it. So AI, it's a much broader field. Machine learning is a subset. So yeah, Lindsay was absolutely correct in how she described machine learning. So basically what it is it's a statistical model that learns by being fed tons of data, and it can then make decisions about stuff like labeling photos. So what we're doing tonight is sentiment analysis. So effectively what we're going to do is we've got a bunch of tweets from Twitter, and it's a piece of text, and we're going to make an AI that can figure out if it's positive, neutral, or negative sentiment. So one of the uses of this would be if you're part of a big company and they want to figure out how people feel about their company or a latest product, you can automatically detect how many people are happy about it or sad about it, or how many people don't care. So yeah, that's going to be the chunk of the work we'll be doing, making a machine learning model that can do that. Yeah, so kind of just to illustrate this whole AI machine learning discussion, this calculator, it's very cheap. You can get it on eBay. Like, this can technically do machine learning, right? It can do a linear regression model. So let me just share my screen 1 second. Share screen. Yeah. So can
Finn, you've muted yourself.
Hello.
Sorry, we can hear you now.
Okay, lovely. So yeah, can you guys see my screen?
Yeah.
So this is the very basic, it's kind of like your bread and butter of machine learning. It's a linear regression. So one of you mentioned you've done stuff with house prices. So you can imagine that to predict house prices, you could use that. So this calculator can technically do machine learning. But to me, I don't know, I think when you're talking about like AI machine learning, I think it's good to kind of distinguish kind of simple statistical models from actual kind of models that resemble how the human brain works. So it's not a clear distinction. You can't say, oh, that's not AI, that is AI. But I think if you want to be safe when you're talking about AI, you talk about deep learning, right? Deep learning is like these really sophisticated mathematical models that kind of have their history in people who studied the human brain, neural networks. So what we're doing, it's machine learning, but in my view, it's not the strongest example of AI, because it's not doing that much that old methods from decades ago could do. But what we are doing is we're training it on so much data that it's actually going to have pretty good results. So that's what's exciting about all of this, really. So to begin with the actual technicalities of this, so we are going to look at a data set, and there's going to be a bunch of stuff we have to do to the data set. We need to pre-process it. We need to turn it into vectors, and then we are going to actually make a model that uses it. So just a discussion, can someone maybe explain for a minute or so what vectors are? What a vector is? No takers? Nigel, have you come across vectors teaching mathematics?
So I was looking for my unmute.
Oh, no worries.
It's got magnitude and direction.
Sure, sure.
That's
So,
an academic version.
Sure. Yeah, so that's very interesting. So that is vectors. That's more in the context of physics. In computer science, vectors are basically just a list of numbers. So what a vector is for what we're doing is it's kind of a way of representing text as numbers, because the machine learning model, it can't use text. It's not wired the way we are. It needs numbers, and then it can find relationships between those numbers. So as an example, you could store house size as a vector. A vector is very simply, it's just a list of numbers. It gets more complicated than that, but for what we're talking about. So yeah, you've got, as an example, its length, width, and height. You could store as a list 10, 5, 9. And now if you had a bunch of different houses, each with different vectors, you could then say, this house typically has this price. Since this house is similar to this house, it'll probably have a similar price. So that's kind of, if you're breaking it down to its constituents, that's kind of how most of these models work. So yeah, let us dive into the coding then. So I will share some links with everybody. So you want to go to that first link I've just sent you, Playground Notebook. Right, so if you guys just want to flag up, if you've got the notebook, and if you can type in print, hello codebar. So let me know when you've managed to do that.
It's saying it's read only for me. Should it say that? And that I can't edit it?
Oh, that should not be saying that. Okay, interesting. So
Open in Playground.
Yeah.
yeah,
Okay.
if you play open in Playground, that's it.
Okay. Yeah, there you go.
Thanks, worked for me.
Works for you? Okay.
Yeah, me too.
Lovely, lovely.
Yes. Yeah, same.
Mhm.
Yeah, it works for me too.
Okay, great. Anyone it's not working for? No? Okay. So just before we dive into this fairly complicated data science stuff, just a bit of a refresher. We're going to play with stuff that's a bit like the building blocks of the actual data science. So those of you that have done Python, that have done some courses, probably be quite easy for you, but nonetheless, it'll help you to understand what the data science part's actually doing. So to start off with, we're just going to code a simple function. So to code a function, for those of you that don't know, you type in def or define, you call it whatever you want. I'm going to say name greeter. Then it's going to take in a variable. So in this case, it can be any name because it's just a variable name. So I'm just going to call it name. So yeah, if you guys just want to code along. And then what I'll do is I'll just print name plus, no, rather I'll print the word hello plus name. So yeah, very simple stuff for those of you who've done coding. Those of you that haven't, this is pretty much one of the most useful things, making a function. So if we give it a test, if you just type in your own name, so in my case, Finn, hello Finn. Okay, so just to get a general feeling, in terms of coding, how was that? Is everyone comfortable with that? Yeah, I'm here seeing some nods. Yeah. Okay, great. So we're gonna have a look at dictionaries. So a dictionary, very, very useful. So basically you structure it like this. So I'll call it my dictionary. And it consists of things called key value pairs. So basically, you assign a key like this. You say, call it key 1. You make it equal to whatever the value you want. So let's just say 100. And then it works like a dictionary, as if you were flipping through a book and you've said, what's the definition of key 1? Ah, it's 100. So then all you have to do is type that and you should get 100. So yeah, that's very basic. So how this is relevant to data science is data sets are structured like this. So effectively, if I show you a data set on my slideshow. So you see here, you've got a data set, you've got price, floor space, rooms, lot size, etc. On the top, and then on the left, you've got the actual values. Sorry, yeah, for each column, you've got the actual values. So what you can think of is if we look at price, we go back to the dictionary, we can say price is equal to a list. So as an example, we are seeing prices. So let's say 1,000, 2,000, 300. So now basically what you've got, if you go to your dictionary, so you've got a list. So the way that this will look in data science is you'll have price as the column name, and then all of those values underneath as the rows. So as an example, it'll look like that. It'll look like price, number, number, number. So you'll have multiple keys. So I'll add another one. I'll add size. I'll say is equal to 10 for 2. My dictionary. So yeah, so basically key 1 is 1 column. So that could be, say, the floor space. Next, you've got the price and then a bunch of numbers. And then you've got the rooms, and that could be a bunch of numbers. So if you go to the links and you go to dataset, could everyone download that dataset? I will resend the link. So if you just click on that and download that. Okay, can everyone just give me a thumbs up or a yes when you've got it?
Yeah.
Yeah, Great.
Yep.
So it's just a CSV. So just, yeah, once you've got it. Yeah, seeing some thumbs ups, lovely. Okay. Then if you can go to the other link I sent, so the AI notebook link. AI notebook, I've just sent that. So open that one up. And give me a thumbs up once you've got that. And remember, open in Playground. Okay, seeing some thumbs up. Yep, great stuff, great stuff. Okay, so we're going to start off with libraries. So what libraries are is they're very, very useful. So they're basically other people's code. So basically other people have made code that can do these fairly sophisticated functions, and they put them in these neat little packages. So all you have to do to get them is to import them. So import pandas. Pandas is a tool to help you manage data. So if you just press the play button, run cell, that will install all the packages you'll need for this workshop. And then, yeah, we can print hello world. So if you see the word hello world pop up, it means the script is working. Okay, and yeah, so I hope everyone's got the data set. So we have to now upload the data set to this notebook. So what we do is click run cell, where we choose the file and then just upload the data set that I sent you, the Twitter dataset CSV. And when you have uploaded it, you should be able to execute the line right underneath it. df is equal to pd read CSV, and you should see it working. So let me know when you have your data set uploaded, please.
I'm getting an error message. It says maximum call stack size exceeded.
That's interesting. Could you send me a screenshot, possibly?
Let me just try.
Is everyone else having success with no, Nigel? What's it saying, Nigel? Sorry, you're on mute. You're on mute.
I think it's done for me.
Yeah.
It says 100% done. I'm guessing that's
Yes.
success.
Yep. Yep. That would be it. Okay. So.
Can you remind me how to upload it? I just tried running that cell.
So you ran the cell from google.colab, and then the uploaded equals files upload. You executed that?
Yeah, I think so.
Okay, and then did it give you an option to choose files?
Yeah, but the thing I downloaded, I haven't actually saved it yet, so I don't know where it is. I presume it's in my downloads. I haven't got that.
Yeah, sure. Yeah, just have a look, and yeah, you just maybe just search in your search bar Twitter_sentiment. Okay, Lindsay, I'm just having a look at your screenshot. 1 second. That's interesting. Range error, maximum call stack size exceeded. Do you want to try refresh it? It might be because, I don't know, maybe because loads of people are doing it at the same time.
Yeah, I'll give it another go. I'll re-download it.
Give it another go, yeah. I'm seeing some thumbs up, so I think it's all fine for a few people. So yeah. Okay, we'll just spend a couple minutes getting that ready. Please let me know if something's not working. Okay, I'm getting another error message. Okay, Atanas. Upload widget is not starting. So Atanas, if you go to the notebook, and you see this play button. If you click the play button, does that help?
So that's when the error message comes up.
Okay, that's really strange.
I'm in Firefox, so I'll try a different browser.
Okay.
Because it says something about.
Yeah.
It works. Changing
Working.
the browser help.
Beautiful. Lindsay, any success?
I'm gonna try another time. Yeah, it seems to be going very slowly. Maybe just because a lot of people are on it.
Okay, lovely. Yeah, that was my thinking as well. Okay, so is there anyone else who is having some trouble? Or has everyone else got the data set? Okay, it sounds pretty good. So, okay, Lindsay, so give that a go in maybe another minute or so. So yeah, we'll just have a look at the data set. So if you haven't already, execute this. df equals pd.readcsv. So execute that cell, execute the cell underneath, and check the head. So the head is kind of like the top couple pieces of data. Okay, great. So we're just going to have a look at the data before we do any coding. So we've got a bunch of tweets labeled neutral, negative, positive. Each one has a unique ID, and there's selected text, which obviously whoever's made this data set, because it wasn't me, probably just picked the most important parts, or at least what they thought was. So it's kind of important to remember that this labeling, it's actually subjective, and it's not it doesn't give the right kind of complexity to human emotions, because as an example, so sad, I'll miss you here in San Diego, versus my boss is bullying me. Now, those are very, very different emotions, right? You've got sad, which means that, you know, you have a positive relationship with something if you miss it. Whereas if it's bullying, it seems like there could never be a positive connotation, really. So that's just something to think about, is even if we get a model with 98.9% accuracy, that doesn't mean that we as people won't disagree about the success, because it's just, we have different ways of viewing emotions. And just in general, whenever you're looking at a data set, it's always good to spend a couple minutes just thinking about it, thinking about what everything is doing before you start your analysis and your machine learning. So Lindsay, is it working for you yet?
I'm not sure. I can see this thing that you've got here. I'd have responded if I was going so sad. I can see that in there. So it looks like it has uploaded it, but I'm still getting error messages every time I click run.
Okay, so if you click df.head,
Yeah.
is that working?
No, because the previous cells haven't run. It's saying it's not defined.
That's very strange.
Yeah.
Okay, so is it the same error message about the call stack?
Well, now it says the dataset doesn't exist, which is really odd.
Have you put it? So when you do your choose files, that works. You can upload it.
Yeah.
Right, and then do you you've executed df equals pd.read CSV?
That's where the first error message is.
That's where that one comes in. Okay. That is very strange. And I'm not sure anyone else is getting that. Yeah, I don't quite know what to suggest. I haven't come across that error.
I'll just try and mess around with it a little more. And
Yeah, do. And you know, you'll be seeing the results anyway. So
don't want to hold everybody up.
sure, no worries. Okay, great. So we've looked at the data a bit. So now the next step is pre-processing. So basically, we're cleaning the data and we're balancing the data. So what this means is we have 3 different labels. So we've got neutral, negative, and positive. Now, I'm wondering, is it possible that we have more examples of, say, neutral than the others? Maybe there's more data about neutral tweets. And that is the case. So we can run a piece of code to see that. So I'm just going to get it for you. Just give me 1 second. Okay, so okay, so basically what we need to do is you can grab a column from the df by going like this, df, and then type in the column you want, df at sentiment, and that'll give you a list of all of the values in that column. So everyone give that a try. So you should have a list of all of the labels. And then what you want to do is, so again, if you think of this as a dictionary, so I showed you earlier, you've got keys and you've got your pairs, your value pairs. So kind of how this column is it's kind of like a dictionary. So what you can do is for key, comma value. So for every key and value in df sentiment in this dictionary, but because it's kind of a special one, you have to go .items. So then we could say print key and value. And you should see everything. You should see all of the text, all of the labels just kind of pop up in front of you. As you can see, we've got some nans, so some invalid data. Okay, so then what we want to do is we want to count how many of each value there are. So I think we could go ahead and leave this as an exercise. So that's just kind of a clue. So if I print value, yeah, so to get just the label, you would go value at 1. So if you think about it, it's saying there, so let's find a particular tweet. So if we go to the top, 1 second, break. Okay, so basically, what I've done here is it's going to go through the entire column and get the tweet and the sentiment. But because I put the word break here, it's going to do it once and then stop. So the reason it's value and then that 1 there is because basically, if you just print the value, you get a list of two variables. It's actually called a tuple, but I'm just going to call it a list. And then because I put 1 here, I've gotten the number or the value at that index. So if I went 0, because in computer science we start from 0 when we count, you get the tweet, and if you go 1, you get the label. So the whole point of what I'm trying to get at here is we want to count how many neutrals do we have, how many negatives do we have, how many positives do we have. So I'm going to leave that as an exercise. So as a clue, value 1's what you need, and you'll probably have to create a couple of variables. So as an example, positives count. We'll start with 0. So yeah, if you don't have much Python experience, I'll talk you through it. But if you do have Python experience, can you go ahead, code this, and let us know what the answers are?
Can I ask a question?
Absolutely.
So you know how the tweets are like categorized as negative, positive. Did a computer model predict that, or was that written by humans?
Right. So that's an interesting question. So that is all by people, because to be honest, right, imagine that was all by a computer program. If that, say, had a success rate of say 80%, and now we made a model, and that also has a success rate of 80%, then by the time it's the final product, it's kind of not that accurate, because it's always had kind of marginal accuracy anyway. So yeah, this is all people, and then so this is all someone has gone and done each of those. Okay, so can everyone tell me, how are you coming along with the coding exercise? Is it something you think you can do? Or would you like to let me know if you would like some help? I can see some concentrated faces, some confused faces. So yeah, let me know.
Yeah, could you go through it, please?
Yeah, absolutely. Okay, I hope those of you that are a bit familiar are giving this a go. Yeah, someone else is speaking. Hello.
Same.
Yeah, absolutely. So I'm going to create 3 variables to keep count of my positives, neutrals, negatives. So as you can imagine, I'll just go neutrals count, start at 0, and naturally the negatives. So we're starting at 0. So this for loop is like our counter. It's going to go through the column and count each item. So what we can do is, if value at index 1 is equal to neutral, then we know to increase the counter, right? Because it spotted a label. It spotted that, this is a neutral. So the way to increment in Python is just to go plus equals 1. It's the same as saying is equal to neutrals count plus 1. So you're kind of saying my variable is equal to my variable plus 1. And then we're going to repeat that with the other ones. So
you need double equals.
Yes, thank you, Nigel. Can someone tell me what's the difference between double equals and equals?
That's rather a question if it's true or false. So if it's true, it gives back 1. If it's false, it would give back 0.
Mm-hmm. Yeah, so that's exactly it. So double equals, it's comparing. Is this the same as that? If so, do that. If it's just 1 equals, it's just declaring a variable. Okay, great. So we're counting negative. So yeah, we're going to change our variable names, positive and negative. Get rid of break. We don't want to break. And then afterwards, in a new cell, we're going to print positives count. So just make sure that everything is the same. Negatives, neutrals, yep. Print positive count, neutrals count, and negatives counts. Okay, so does someone have some answers for us? How many positives do we have?
I got some answers, but they may be wrong.
That's totally fine.
Oh no, they are wrong. Ignore me. They are wrong because I've got neutral 2 times. It's fine. So I probably have the neutrals. I've got 12,548 and 8,782. So I definitely have the negatives.
Mm-hmm.
I think
Okay.
you've got the neutrals and the negatives there, I think.
Yeah.
Right. So
And then the positives.
yeah.
Changed it now. Yeah.
Yeah. And we can add some writing. So I'll say positive. I'll go neutral and negative. Okay, so it must be string and not integer. So what's happening here is we're treating an integer like it's a string because this is a number and that's a string. So to make it into a string, you just wrap it in some brackets and you say string, and then wrap it in brackets. Okay. So yeah, as you can see, we have, you know, almost 3,000 more examples of neutral than we do positive. And we've got about 1,000 more positives than we do negative. So just have a think for a second. We're making this model that's supposed to predict if a tweet has a positive, negative, or neutral sentiment. So what's going to happen if we have way more neutrals than we do positives or negatives? Can someone tell me?
Maybe to affect its the quality of the predictions for that category. So because there's more data to learn from, you'll be more accurate. Looks like we might have lost Finn.
Yeah, seems like we've lost it.
Did anybody else get a 0 for one of these?
I had a 0 first. You may just be mistaken. Well, not mistaken. You may have just confused because I had neutral twice. My count was right, but I was just having the ifs. I had one of the ifs 2 times. So look at your ifs and look at your counts. You may have one of them 2 times. That's what I got wrong the first time.
Thanks. That's all.
What was the question Finn asked before he left? I didn't get it.
If I remember correctly, he asked what will be the result, or what will be the effect of having very different number of entries in the data table, varying so wild, so sort of big variations between neutral, negative, and positive. Correct me if I'm wrong.
Thanks.
Yeah, that was it. You had a good answer to it, I think.
I have a problem with mine. So I try to like extract how many neutral statements there are, and then when I print it out, there's just like a series of zeros.
You could maybe share your screen and then we could solve it all together.
Oh,
If
because
that's
I'm
okay.
doing it on a different device to the Zoom. So yeah, because the Zoom is on a tablet. So yeah, I won't be able to share my screen.
That's okay. I guess you could just walk us through it. Or
Okay,
walk
so
us
I
through the
set
error.
so I created a variable neutrals equal to 0, and then I wrote for value in df sentiment with the speech marks dot items, a bracket, 2 brackets, and a colon. If a value is enclosed in those square brackets, 1 is identical to neutral, and neutrals, then I created a new variable, neutrals is identical to neutrals plus 1, print, then the string function neutrals enclosed in like 2 brackets, and then it just prints out like a series of zeros.
Did you, when you said if it's equal to neutral, did you put, when it's the double equals, did you put that in?
Yeah, the double one.
It's in speech marks, the neutral, the word neutral.
Yeah, the word neutrals in the speech marks.
Is the print statement within the if statement?
Within the if statement. I don't think so.
Yeah, I think it's supposed to be in a different line altogether. Even a different
Yeah, it's
code.
on another line. Oh, okay. Oh, yeah, that might be the problem. I'll put it in the new code.
Cool.
I'm sorry, I've been scrabbling to catch up because it took me quite a while to fix the workbook, but I've got it working now. And I've run what I think was on what you had on the screen as code, and it's just come up with +0, neutral 1, -0, which can't be right. What did people do?
I can share my screen if you want. If somebody else has a solution, I'm getting lots of, I'm getting something right, but not everything. Bear with me.
Okay.
I think somebody else got zeros in there. I don't know if they managed to fix it.
Lindsay, I just put in the chat my solution. I think I got the same number as Finn. So yeah.
Oh, nice.
Thank you.
But I did it just slightly differently. I used the plus equals rather than equals negative count +1. But yeah, it doesn't make too much of a difference.
Thank you.
So I put the print function on the new cell, and it still outputs the number 0.
Oh, if you're getting 0, maybe have you indented after the 4?
Yeah.
Uh,
The next line, if the if statement, yeah, there's an indent.
yeah, and all that block is indented.
Yeah, after the neutrals, it's like, yeah, I also indented that one.
And do you have different variables for positives count? As in, you should have a positives count at the beginning of your code saying it's equals to 0. And then under the if statement, you should have, oh, sorry, since you're using a neutrals count, you should have one at the beginning of your code saying it's equals to 0. And another one after an if statement saying it's sort of adding onto it, so plus equals to 1 or equals to neutrals count plus 1.
Yeah, I
If that
have
makes
that.
sense. Uh-huh.
Yeah, I do have that. Can I see that main screen again, please?
So how do we do that?
If you can you see the chat, Florence?
I'll check the chat.
You look in the chat. Someone's put a solution in the chat.
Yep, that solution in the chat helped. Thanks. I had mixed up the equal signs.
Oh, yeah, it works. Thank you.
Hi. Does anyone who has like sort of advanced Python knowledge maybe suggest cool projects to do or resources to use to build projects?
I don't have advanced Python knowledge, but the 2 books that I've been using that have been really awesome, I don't know if you can see them, is this.
I've seen the book online. Yeah.
They're really, really good. They've got, they take you through the basics, and then there's projects halfway through that you can start getting your teeth into, and they're really, really helpful books.
Oh, that's great. Thanks.
Somebody tweeted that today. They're almost giving them away for a few quid, the PDF versions at the moment.
I think you can get the PDFs for free actually, but I think it's worth buying the books, because going between PDF browsers and trying to do it online, I don't think that would really work.
Oh, what was the book called? I couldn't really see it properly.
There's two of them, that's one.
I think because, oh,
Yeah,
yeah.
great.
And then the other one is same publisher, Python Crash Course. You can get free PDFs, so if you can print them out, maybe that's a good way to do it.
Yeah, I mean, yeah, like I don't really have advanced Python knowledge, but learn Python the hard way. I started with that. I don't know if it's still free, but that was quite good. Probably don't use all of those. There's some things that's probably more useful than the other. And it can get quite dry if you're more like a hands-on person. So like make sure that you mix that with like learning some frameworks, like maybe if you want to like build a web app using Flask or Django, or even just like play around with the data like on Kaggle, there's some like competitions. So like just use those and just like crunch some data using Panda, so the library that Finn explained earlier. So those things like, you know, I think is quite interesting. Yeah, but yeah, if anyone has some other stuff, that'd be quite helpful as well.
I've mostly just used Data Camp, so I think you can get it for free for like a month or something. That was a while ago. So I've used that, but not too much. So I've not actually used many courses in Python. And then I also attended a Python course in my old workplace, which they're running it online now, but I'm going to look into it actually, because I think they started it online. It's called It's Her Future, and it's run by KPMG, and it's a Python course, and it's free and it's online. But I think they're like midway through, so I'm going to take a look and see if I can like find any links or something that I can share with you. I've done that, and then I went on to help them with it. That's focused more on scripting, so that was quite good because now I'm using Python. I've stopped using courses for Python because now I'm using Python in my job. So we're using two Python libraries, Troposphere and Boto3, to write scripts and automate like cloud templates formation. So if you're into Python, using Python for the cloud, it may be worth looking into Troposphere and Boto3. But I'm going to take a look and see if I can find links to the online KPMG course to share that with you right now. So
Thank you for holding the fort, Mira. I'm so sorry.
It wasn't me. It wasn't me. You just happened to come back when I was speaking. It wasn't me. It was literally everyone else.
You've taught them AI. Thank you. Yeah, so sorry about that. Wi-Fi, everything just cut out. So I think we probably just want to speed things along. So again, my apologies for that. So we were talking about rebalancing. Can everyone, let me get my screen share back on. Okay, can everyone see my notebook, my code? Yep, great. So what we need to do is rebalance it. So we know that we have way too many neutrals. So why this is bad is because if you've got a model and it's trained mostly on neutrals, it's probably going to be pretty biased to saying that, and say if you have a new tweet, it's probably going to say, probably neutral. So what you want to do is you want to have even balanced classes. So you want the same amount of positives, neutrals, and negatives, because it's not biased. It's not going to be more likelier to say that that is neutral. So yeah, there's a simple way to do this. So we're going to say our df. So let me just write it out for you. So our df, which is data frame, is equal to pandas.concat. Pandas is the library. We're calling the library. Concatenate means to join. So we're going to go df sentiments is equal to neutral. So for those of you that haven't really dived into pandas, which is probably most of you, what's happening here is basically I'm just saying choose all the values that have this label neutral, and then from this range, which you can see there is actually the number of neutrals minus the number of negatives. So it's kind of like the range. It's because most of them are neutral, the least of them are negative. So what we're doing here is a bit of fancy code to just drop all of the excess neutrals, as well as the excess positives. There's a couple positives. So yeah, pretty much just, what I'll do is I'll copy and paste that on the Zoom chat. So let's just write it properly. I've got the word balance here. Just replace that with your data frame name. So df. Effectively what it's doing is it's creating two different data frames, some consisting of the originals and some are more like there's a particular amount of neutrals. So what it's doing is it's joining those. So it's kind of almost like you know, making the neutrals even bigger, but then what it's doing is it's dropping all duplicates. So it's all of the duplicated data is being taken away, and we're choosing how much of it has been duplicated. So that should effectively leave us with a balanced class. So just make sure that that's all good. So let's have a look there. So that's executing. I will send that over in the meantime. Everyone. Okay, so I think that's worked. So now we're going to do what we did earlier. We're going to count how many we have. So if I execute that piece of code again, and I execute that again, we see that, okay, we've taken too many neutrals out. So what we need to do is actually just come up with a formula. So I kind of put in these numbers by hand. So if we actually just get positives count, sorry, if we get neutral counts, and we say, okay, minus that by the difference, sorry, one last attempt, this should be negatives count. So what we're saying is count from 0 up to negatives count, and then don't get any more beyond that range. Okay, so let's test that again. Okay, we're running some problems. So what we're going to do is, because we kept changing the data frame, we need to read it once and then make it into a copy. So say, we'll say df backup equals df.copy backup. So now we've got one that we won't really change. We can just call it. We can say df is equal to df backup if we want to start fresh, which we do indeed now. So df is equal to df backup.
Shall we also do that?
Hello.
Hello, shall we also do that?
You see what happened is I executed it. So if you've executed that code I just showed you, then yeah. But if you haven't played with it, then don't worry about it.
How do you know if you've changed the original or if you're working with a view?
So if you're working with a view, well, typically, like if you're saying it's equal to, then that will just make sure that the data frame is whatever you've said. So this won't be a view, this will be an actual data set. So yeah, I'm not having much luck. So let me just grab my original code, which was not having difficulty. Yeah, I'm not quite sure what's happening there. So if I go to AI notebook, so if I get my DF back up, if we do the count like we did, we're getting the same, no, we're not getting the same results. We've just lost a bunch of data. In that case, we will get our backup. Okay, so that's how it was. And then in this particular case, if we rerun that, we are losing too many. Okay. That's interesting. So
some reason for me it worked. The first things you wrote even
it
them out.
worked.
Even them out, yeah, completely.
Oh, that's brilliant. Do you maybe just want to send us a screenshot or send me a screenshot and I can share it with everyone? So the one thing about coding in public is you're kind of, if there's stuff that you've kind of not done perfectly, you get wasting time on it. So I do apologize for that. Okay, so then again, if I count that, okay, can you send me that screenshot? I'm just wondering if.
Yep, sent it.
Yep, thank you. Okay, so balance library. Okay, so in order to keep things moving, I'm not going to worry too much about that. So we're just going to keep our data frame as it is. If it's worked for you, well done. But if not, we can just look at the accuracy and probably say we could get it 5 to 10% if we balance it. So that could be kind of an evaluation for when we look at the model's results. So we're just going to get rid of all of that for now, but it's important in the future. Remember, balancing your classes is a good idea. So I will just clear all of that. And we will look into how we prepare the data for the training. So again, just having a look. Okay, that's our data set. It's not quite clean. Okay, there we go. So next bit, pre-processing. So basically, if you look here, we've got stuff like apostrophes, exclamation marks. So as an example, say you like Ben and Jerry's, you might say something, you might tweet, I love this ice cream, comma, whereas someone else might say, I love ice cream, exclamation mark, and someone might just say, I love ice cream so much. So when it's kind of looking at these words, it's going to treat that cream, comma, cream, exclamation, and cream on its own. It's going to treat them as different words, which we don't want, obviously. So what we need to do is just strip, get rid of all of that. So I've got a bit of code that does just that. So put that in there, code. So it's clean text. So basically all it does is it checks every character in that word. If that character isn't in the alphabet from A to Z, it's just going to ignore it. So let's see how that looks. If I go clean text, I love ice cream. As you can see, it makes it lowercase because that's part of what we're talking about. It'll treat upper and lowercase words as different. So if we make it all lowercase, it'll kind of treat everything sensibly. So yeah, what we do is take this function and apply it to the whole data set, right? So the way to do that is to go df at text. And then what we do is we say is equal to df at text dot apply. So what this does is it allows us to apply a function. So in this case, what function should we put in? Does someone want to give me a suggestion? What should I put in apply here?
Maybe we try to put the function that you defined at 115 clean text.
Absolutely. So it's a bit weird. You don't need to put in brackets, just put in the function name. And that should do the trick. Oh, okay. So what's happened here? Float object has no attribute string. So basically, float is kind of like, it's a number with some decimal places, whereas string is a word, or, you know, kind of a sequence of letters or characters. Because we're trying to split everything into characters and then choose the correct characters. So I'm just wondering, what is this? Why is there floats? I thought we were dealing with strings. Well, it's because of those nans. So we can count how many null values of data. It's basically missing data. And it puts in the word null. So just grabbing a piece of code. So what we're doing here is we're going to count. So what we're going to do is len stands for length, the length of the data frame. So how many items do we have? 31,015. And then what this next bit does is it tells us the length of all of the values that have a null, that basically are missing the text data that we need. And what we're doing is we're minusing those two lengths to find out the difference. So in this case, it's saying that just give me 1 second. Right, so, okay, so what's going on is we're choosing the whole data frame when really what I should be focusing on is the column. So to do that, I go to the column, I say text, and then what I say is, okay, so in this data frame, return all the places where the text column is not null, or just not null. Okay, so as you can see, it's basically all of them. There's actually, because we had 31,015. So if we do the opposite, is null, there's actually only one bad piece of data. So that's pretty good. So what we can do is to get rid of all null data, we just say df is equal to df at df text dot is dot not null. So basically what we're saying is our new data frame is the data frame where all of the text was not null. Because if you try to do it with null, with this NaN, you get that float issue. It's considering NaN to be the wrong data type. So let's see what happens if we run this function after we've cleaned it up and gotten rid of the nulls. We see that it seems to be doing the trick, nothing's crashed. And we will see what the result is when all of that is done. Okay, great. So we have a new column. Sorry, text has now been cleaned. It's all lowercase. There's no apostrophes, exclamation marks. Really, really, really important in dealing with text data. Okay, so the next part is of something called one-hot encoding. Has anyone heard this term before? And would you like to tell us what one-hot encoding is? Any ideas? It's a weird phrase, one-hot encoding. Okay, so basically, we talked a bit about how computers can only understand numbers. So basically what we need to do is instead of the word neutral, negative, and positive, we want to use numbers or vectors. So there's a library that does that for us called sklearn preprocessing. So basically, you just have to type in that piece of code. And let's see what the result is. Okay, df. And check your df.head. So you'll notice here 1 and 0. And 2. So I think what you're seeing there is effectively it's considering so sad 0 to be negative. 1, let's have a look. If we scroll back up, neutral, sad, and negative. So it's treating neutral as 1, negative as 0, and positive as 2. So again, just converting text into numbers. In this case, we've got 3 different numbers. Yeah, so that allows us to train a model using numbers. Do we have any questions so far? All good.
I was
Okay,
going to
so
ask for the code of the clean function that you wrote earlier.
yeah.
But
Okay. Let me clean it. Yeah. Clean text. Okay, I will send that over.
Awesome.
Okay, anything else? Any other bits of code that you guys would like me to send you?
I didn't get all that last encoder bit. I didn't.
You didn't get the encoder bit, no worries. Okay, so I think what I'll do is I'll just copy, I'll share this entire notebook. And then you can just copy and paste all the codes freely. So copy link, let me just rename it so there's no confusion. Call it Finn's code. Finn's code, okay, share. I will get the link. Okay, that should do the trick. And here it is. So yeah, if you go there, just copy and paste all the bits of code. I think it should update as I add more stuff to it. Okay, so the next part, we're getting into kind of quite tricky territory. Just thinking of like general kind of coding and computer science stuff. So we're going to talk about text. So the thing with text is that when you want to represent it using vectors, there's actually many ways to do it. So I'm just going to talk about two ways. I'm just wondering, if I go to my slideshow, can everyone here see bag of words, or is it only that tab that I'm sharing? Can you see bag of words right now?
Yeah.
Okay, lovely. So yeah, bag of words, basically it's a vectorization method, and it's the simplest one. Effectively, all you do is you take a sentence and then you kind of make that your row. So the cat is cute, the dog is cute. And then you see here all these words. These are all of the unique words throughout all of the documents. So the cat is cute dog. So basically what it's doing is it's saying, okay, the is in that sentence, cat is in that sentence, dog not in that sentence. And then the next one, the in that sentence, cat not in that sentence, dog, one, yes, is in that sentence. So it's not too complicated. Basically, it's kind of useful for finding how different two pieces of text are, because it's showing which one has some words and which one and which the other one doesn't have. But it's not very good because it doesn't really give you an idea of how important a word is for a piece of text. So we're trying to find out what makes a text show positive sentiment. You know, we're using the word cute twice here for each one. And kind of like it's just saying cute appears or cute doesn't appear. It would be better if we got some kind of idea of how important it is, especially if we're dealing with tweets with multiple words. So that brings us to Tf-Idf. So I'm not going to get too deep into how this works, but basically what Tf-Idf does is it gives you vectors that shows how important a word is for a particular sentence. In our case, we'd probably expect love to be quite a strong number and hate to be quite a strong, the word hate to be quite a strong number, but the word okay should kind of be a weak number, possibly even 0. So Tf-Idf, a score of how important something is. So using, so trying to solve the problem that we are, which do you think seems more appropriate to use? Bag of words or Tf-Idf? Lisa, do you want to have a guess? Okay, so basically Tf-Idf, right? Because we don't just want to see if words appear or don't appear. We want to get a bit more information. So finding out how important it is really useful. But there are loads more ways to vectorize it. Okay, so I'm grabbing a piece of code that allows me to convert text into Tf-Idf vectors. So there it is there. So basically what I'm doing is I'm importing a library. So someone else has coded this, has coded the actual model. I'm creating a model. Then what I'm doing is basically is a fit transform. So without getting too deep into this right now, what it does is it kind of uses the entire set of documents. Then it compares each individual sentence to that document, and then it gives it a vector, a unique vector that identifies that tweet. So yeah, you can type out this code here. Instead of test df, just put in df. And then what we're doing here, I'll come to in a bit. But that should do the trick. Okay, so what I've done here is I've used the word prepared text. It should just be text. If we look at the data set, yeah, it's called text. Okay, so that seems to have done the trick. You'll see here vocabulary. So I'll get back to what the vocabulary actually does. It's useful for after you've made the model. Okay, so the next bit, you've got X and Y. So those of you who have done a bit of linear algebra, a bit of maths, you've kind of got your X values and your X values and your Y values, right? So if I just go back to my slide, so you see here on the left, we've got a linear regression, right? X-axis and Y-axis. So basically what you're trying to do is, we've got a set of X values, which is basically the text. Now that we've represented it as vectors, we can kind of come up with plots that show us the relationships between these values. And then the Y-axis is kind of like your labels. So as an example, if we go back to housing prices, it makes sense that the final housing price would be Y, because it's kind of, if you take all of the factors that determine house price, which is your X values, you'll be able to get your Y value. So in this case, we have to choose our X and Y values, because what we're trying to predict is the sentiment. What should the Y value be? Can someone tell me? What should our X value be and our Y value? Any ideas? So if we do the analysis, yeah, Lisa?
I don't know.
Okay, sure.
Sorry. I presume it's going to be the sentiment and something. The bit we got from the last bit, the vector we got from the last bit of code.
Yeah, so that vector you're talking about, is that the X or the Y?
That's going to be the X. Possibly.
Absolutely, right? Great stuff. So yeah, if you think about the house price, kind of like, in this case, the house price is the sentiment, and the factors are the text. So we are going to say that. So we're going to say X is equal to transformed. Remember, that's what we called the vectors. So transformed. Our Y value is then as Lisa said, it's the sentiment. And we can just double check to make sure that. So it's saying X is a sparse matrix. A matrix is kind of like a collection of numbers, in this case, vectors. So don't worry too much. It's just a language the computer understands. And Y, as we said, that's just representing your labels as numbers. Okay, sure. So we have cleaned the data set. We've tried, well, I tried my hand at balancing it. Some of you had more success than I did. So that's kind of preparation, not really the exciting bit. The exciting bit is then actually using a model, doing the machine learning. So I understand we've got 20 minutes left. I'll probably carry on talking for a bit after that, but I hope that we all leave with a better understanding of machine learning. So as you can see, I've got a linear regression and then a logistic regression. So what a logistic regression is it's basically a model that whatever values you give it, whatever text or tweet you give it, it'll give you either a 1 or a 0. So it's kind of saying it's either this or that. So if we just had positive and negative, what you would have is you would say, it's either positive or it's negative. As you can see here, this bit in the top right corner, that's probably going to say positive, bottom left corner negative. Generally, it's very good at saying one or the other. You might get something slap bang in the middle, but probably not. So what we're doing here is different, right? Because we've got neutral. We have 3 different labels. So basically what we're doing here is we're doing kind of a modification of logistic regression called Softmax. So basically what Softmax is you can have multiple labels, not just either 1 or 0. Because what it does is it gives it in terms of probabilities from 0 to 1. So any particular probability is a particular class. So this thing might have a 60% probability of being negative, 40% positive, and 0% neutral. Then it'll just label it as positive, the highest probability. Okay, any questions on that? On the model or anything that we've done?
Sorry, could you please repeat that logistic regression part again? We have y 0 and 0 to 1, but we have 3 different levels. Could you please repeat that again afterwards?
Yeah, sure.
Thank you.
Yeah, so, yep. So in this case, we need a different model. So what Softmax does is it's a mathematical model where basically instead of just having like a binary 0 or 1, it offers a probability. So it'll say there's a particular probability of it being positive, particular probability of it being negative, particular probability of it being neutral, and then whichever one's likeliest, that will be your label, your sentiment. So I'm not really diving into the maths, but you can just look up Softmax if you want to figure out the nuts and bolts of that particular model. Does that answer your question? Lovely. Okay, great. So on to training the model. So what we need to do here is we need to split the data set because we've got our X and Ys, but we also have a 2-step process when building a model. So basically you need to split it up. You need to split it into training and testing. Training is what we're going to use to teach the model. It's kind of like when a child sees a bunch of examples of something, it can then figure out how to do it on its own. And then testing, what testing is we're taking a bit of the data and we're hiding it from the model. Because then what we can do is, after the model's learned how to predict sentiment, we can then see how good it is by using this testing. So in this case, I'm using a logistic regression model. You can use many, many different models, and I'll show you how to find and choose different ones after this. But basically what we want to do is we want to see if we train this logistic regression model, the machine learning model, how good is it at saying what the sentiment is? So let's find out. So yeah, I will just copy and paste this code for people to put into their own notebooks. But I think if you just refresh that link I sent you, if you just refresh that page, you should be able to get that code as well. But I'll just send it here anyway. So this is how you split your data into training and testing. Okay, let's see what the result is. Number of iterations reached limit. That's very interesting. Could someone else tell me if they've ran this code as well? Ah, here we go. So I've gotten a result of 0.68% accuracy. So basically what this means is when we made this logistic regression model, it's getting the answer right about 70% of the time, which is pretty good. If you think about it, it saves you tons of time from having to hire someone to pour through thousands of pieces of data. So I think probably what would be good is if we just test it by choosing our own tweets, just pieces of text, and we see what it thinks about that, what it says. Is it happy, sad, or neutral? So I'm just going to grab another piece of code. So I've created a function here. It takes in a piece of text. Then what it does is it kind of vectorizes that text again so that the model can use it. And then what it does is it gets the model called logreg, and it gets a prediction what the model thinks it is. Is it happy, sad, or negative? So can someone give me a sentence which has a pretty clear sentiment? So someone just say something that's either happy or sad. Mira, want to give me an example?
I kind of like dogs.
I kind of like dogs. Neutral. I mean, you could argue that is pretty neutral, but you could argue it's also kind of positive. So, so to kind of put some context, let's think of a strong one. So maybe something like, I hate global warming. Negative, right? Good. But then, but then if we put something like, say, I'm fond of chocolate, clearly positive, right? It's saying neutral, because does someone want to give me their thoughts on why it thinks this is neutral? What's gone wrong? Any theories?
Maybe the probability wise it wasn't too positive, or maybe the data set accuracy is not good, so it's not able to do this, or it didn't have enough data on this sort of situation. I don't know.
That's it, not enough data. Fond, it's not the most common word. Love and hate, very common. You'd expect to see it a lot in the tweets. So as Leah just said, the trick is just to have way more data, which is, you know, it's doable. But there are other ways to get your model more accurate. You could even just choose a different model. So one thing that has gone on is that we've cleaned the text, but we still have these words that just aren't really that meaningful. For example, words like the, words like on, kind of technical words that just don't convey emotion. These are called stop words. So before we actually process the model, it's a good idea to get rid of stop words. So I'll show you what that looks like. stop words, just grabbing some code. Okay, here we are. Okay, so it just splits sentences into words, and if the word is a stop word, aka it's meaningless, it gets chucked out. So what we need to do here is the same way that we turned the sentiment from labels, from words into numbers. We're going to use the same process, the dot apply. So if I go df at text is equal to df at text dot apply, and then we fill in the function, right? Okay, so let's see. Let's have a little before and after. So this is how it currently is. And this is how it looks after we filter out stop words. I'd responded going versus I'd have responded if I were going. So sad, miss San Diego. So sad, I will miss you here in San Diego. So you kind of got slightly caveman talk, but you know, it conveys kind of emotions much more clearer. Because basically words like the and if, they kind of just get the model confused. It's called noise. It's not meaningful. It doesn't improve accuracy. So our initial model had an accuracy of 68.3%. So I'm wondering, do you guys think this will improve the accuracy, or will it decrement the accuracy, decrease the accuracy? Do we have any, can we have a vote? So give me a thumbs up if you think it will decrease accuracy. This could go either way, by the way. This could go either way. Okay, not many thumbs up. One thumbs up. Okay, 2 thumbs up. Steve feeling a bit brave. Lovely. Okay, so let's have a look. So current accuracy. Oops. Okay, so let's have a look. So we basically just need to refresh everything with our new text. So I'm just going to reset everything. Ah, okay. Sorry, Steve. Sorry, whoever, Lindsay. Turns out we get a bit better accuracy with taking out stop words. But you're not wrong, because I've done this before with like a sarcasm data set to detect sarcasm in data, and actually keeping in stop words increased accuracy by about 3%. So it's well worth looking. Sometimes stop words can actually contain important meaning. But generally, it's a good idea to get rid of them so that you can focus on the keywords. Okay, so we've talked about pre-processing. We've talked about getting the model. So I guess now what we want to do is actually figure out how we can get better accuracy, right? We want to be able to make this a product for a company, let's say. So I said logistic regression. It's a very simple model. It's not very clever, as you could see. But what it does offer is something called a baseline. So basically, we now know that without too much work, without anything too complicated, we can get about 68% accuracy. So now this is the point where you start thinking, okay, let's try possibly some deep learning, possibly a neural network. But what I think might be a good one to see is something called a support vector machine. A support vector machine, it's a very old model, and it's kind of was one of the original neural networks. So a neural network is basically a model that kind of resembles the human brain in how it learns. So yeah, just taking a more sophisticated model, let's see if we can get that accuracy from 68% to hopefully possibly 70 or even 80%. So it's very easy to find new models once you understand how to use one. So for our example, we're going to try out support vector machine. Vector machine. So I just want to show you an image. So basically, it kind of creates this boundary, and then each side of the boundary is a different class or a different label. So it's kind of similar to a logistic regression. It's just a binary classification. So I'm going to pull out a piece of code that I used for a model when I was trying it out on a sarcasm detection model. Right, give me 1 second. Okay, here we are. So as you can see, it's just a few lines of code. Again, I'm using libraries. So someone else has basically gotten the maths and they've made it into a library, which is really neat because it allows people to actually just with a few lines of code, actually test out some pretty sophisticated models. So as I was saying, support vector machine, we need to fit it. Fit it is when you're training the model. So in this case, we're going to put in our training values. So X train and Y train. Okay. And let's see, how good is it? Does it boost the accuracy? As you can imagine, the more sophisticated the model, the longer it takes to train. Sometimes you leave it running overnight, especially if you have lots of data. Okay, so while we wait, do we have any questions or is there anything else we want to know?
Yeah, so just wondering, what are the kind of resources that you would recommend to kind of get stuck hands-on with these? So, and also another question separate to that. So I went to a Microsoft sort of event, and they had very easy to use machine learning, like training the model and this sort of, I can't remember what it was called, but it was a very easy to interact UI, and you, yeah, I can't remember what it was. But what do you think about this? What's your view on this one?
I will answer that. So just one thing, I didn't name my variables properly. So I'm calling that my support vector machine. So this should be the model. Okay, so to answer your question, what there are, I think what you might have been talking about with Microsoft, there's stuff like Azure and Amazon Web Services and Google Cloud. they offer machine learning models that have already been built and configured. So it's very easy to use them, even if you don't know coding. So if people want some links, I can get Kim to email out some links about that. The downside to that is you're probably not really going to be learning that much or doing that much yourself. I think it's useful from more of like a kind of a product manager kind of view, but what I'm kind of hoping to do here is get people interested in the technical side, because that's kind of what I'm interested in. In terms of getting started, in terms of learning data science, there's some really good Udemy courses. There's specifically one called the Data Science Bootcamp, the Python Data Science Bootcamp. Has anyone else tried that one?
No, can you please send us the link?
Yeah,
Please, thank you.
Absolutely. I'll get some links emailed out to you, because I understand a few people have tried out Udemy. So yeah, that would be good. Basically, everything's there and it's free. So what I would suggest is what you could take away from this workshop is basically like the bread and butter of a typical approach to data science. So what you want to do then is basically learn some Python. So I'll send out some Python tutorials. Then after that, you want to get into pandas and NumPy. Those are the tools that have allowed us to use data frames. They've allowed us to manipulate data really easily. Once you're comfortable with pandas and NumPy, then start looking into the machine learning models. Typically, resources like scikit-learn, they're the ones who make all of these models that we're training our data on. So yeah, pretty much that's a pretty good trajectory, I would say. But again, I'll send out some more links and we can perhaps have a bit more back and forth discussion about how to get stuck into it. Okay, so let's have a look. We've got our Y predictions, so we need to see the accuracy. So in this case, our accuracy is our Y predictions and our Y test. We've improved the model by 1%. So what this shows is that basically, thank you, Yuka. Basically, this is testing. We're learning. We're figuring out. Okay, support vector machines do better than logistic regression. After that, you can kind of start to get more into the theory, reading some textbooks and some research papers, and you can figure out the mechanics. Why, say, support vector machine is better than a logistic regression. And you can also then ask yourself, okay, support vector machines, they're doing this, they do better than logistic regression. So it's conceivable that a more sophisticated model would do a lot better, right? So at that point, you could think about trying a neural network, a deep learning model. It's not too different from what we've been doing here. You can import libraries, execute it via a few lines of code. The sort of downside is it'll take much longer. And also the downside is that if you have to explain this to someone, maybe a supervisor, it's very difficult to explain it if you're kind of just using libraries. So it helps to kind of read a bit about the maths behind it. Logistic regression is probably a good starting point if you're interested in the theory. So read about that, learn how it works, and maybe try figure out why it deals with text data reasonably well. Okay, so I think that is it, but I'm happy to take any more questions or if there's anything anyone else wants to look at.
It's not a question, but would you be able to share your Jupyter notebook that you prepare for this workshop?
Yeah,
Thank
absolutely.
you. Yeah, and also I have a question. earlier, I'm fond of chocolate was what was that? Was it neutral or something?
Yeah.
To improve particularly this sentence, would you be able to, I don't know, put like I'm fond of, as in like categorize in positive? And then do you think that's improved the model, or doesn't make sense?
Yeah, so it would improve the model. So I think that's quite interesting. So basically, as you kind of dive into data science, you figure out there are tons of resources and tools. So as an example, there are tools that have kind of models that are pre-trained on words like fond of. So it knows that fond of is positive. So then, as you were saying, it would get much better accuracy. But what kind of a limitation of that is that we're trying to make this as automatic as possible. So we're in a stage where there's so many tools and resources other people have done that we can pretty much do what you just said. But if you're kind of just starting out and just seeing what works, you kind of don't want to do anything yourself, because there are, you know, thousands of words that indicate a positive sentiment, you know, and to do that by hand is really time consuming. But as I said, people have created tools that inform the model about things like that. Does that help, Yuka? Lovely.
Yeah, thank you.
Okay, if we've got a few more technical questions, then let me know, or if you're just anything pops into mind.
I was just wondering, which model do you use the most?
So that's a tricky question, because
I guess it also depends on your data.
exactly. It's really good to have baselines. So logistic regression and linear regression, it's really good to start with those and then see if you can get your accuracy higher. There's things called decision trees and random forests. Basically, excuse me, a decision tree basically says, so once you've trained your model, it can say, if fond of is in sentence, it's happy. If hate is in sentence, it's sad. So it does that automatically. And then a random forest, it kind of takes all of those, basically it does sort of many different decision trees, and it gets them to vote about which label it think is most likely. And I found that has really good success for problems like this. So that's worth trying out as well. Decision trees, random forests. Yeah.
Okay.
Okay, it would be good to get everyone's feedback. So I apologize about, first of all, the Wi-Fi cutting out. Second of all, I got stuck on the balancing bit because it worked the first time I tried it, and after that, it just wasn't quite working. So just in terms of a workshop, do you guys have any suggestions about going forward, how we could make it more tight and productive? Do we have any feedback? And be as honest as you want.
I think this was fantastic. I really enjoyed it, and I did manage to pick up some keywords that I can research a bit further.
Okay. Yeah.
Maybe a learning outcome kind of statement at the beginning, or a roadmap. I would have found personally, you know, something that you know, might make it a little bit better for other learners. But otherwise, amazing. Yeah.
Okay, fantastic.
I don't know if it helps you for future events that you run, but the problem I was having with Colab was it doesn't like to run on Safari. So when I open Chrome, it's fine. So you might want to know that for future events.
Yes, that is extremely helpful. Okay, so one thing that kind of popped into my mind was the fact that I'm sitting here and I'm kind of doing a lecture. It's supposed to be a workshop. Obviously, we have to figure out, do we want to get a high level idea, or do we actually want to be able to code it? Does anyone feel as though they didn't learn as much coding as they should have liked to? Feel free to thumbs up or just talk to me if you felt like should have been more me coding.
I think the thing with the coding bit is once, I don't know, perhaps it probably depends a bit on how much Python you already know, but I found I didn't want to spend too long on that bit because it's something I can go back and look at, whereas the ideas I found more useful because it was explaining the different ideas, and then I can go back and look at the code in a bit more detail afterwards. But I don't know if that's, I guess it depends on how much Python you know. But
yeah, Lisa, yeah, absolutely. That is a lovely outcome. I'm seeing some thumbs up. Is that people agreeing with Lisa, or is it you wanted to code more? I can't quite tell.
Yeah, I agree with Lisa. Yeah, like she said, we can always go back to notebook or something if you could share. Yeah, like I think I have learned a lot about theory and also like outline like what I need to do to predict text and negative and positive and then neutral. That was really important for beginners. But if I want to take it further, then I don't really need a coding lecture. Just yeah, share the notebook and explain like all the steps that you're doing and then like intuition behind or something.
Okay, lovely. Yeah, I will send a nice polished script for everyone.
Yeah, I think I definitely, I think we've covered so much over such a short time. I personally do prefer coding things myself. I do like seeing those errors, and if there's some syntax errors, you know, resolving those, I find that kind of more my style of learning. But I think given the time, I think this was really good to get us started and actually do this in our own time. So thank you very much.
Okay, sure. That is good to know. Okay, so I guess what might be useful is I could just talk about kind of data science and machine learning. Feel free to stick around. Feel free to. We're past the time, but I'm happy just to talk about machine learning in general. So basically, there are many different fields and there are many different careers. So how many of you think you kind of want a career that relates to data science and machine learning? Just give me a thumbs up if it's something you've kind of got. Yeah. So I'm seeing, yeah, seeing quite a few thumbs. Okay, lovely. So like you can get very technical, which is machine learning engineer. If stuff like figuring out why support vector machine is better than logistic regression, if that was really interesting to you, you might be really well suited to that kind of position. Whereas a data scientist, they're a bit more interested in prototyping things and seeing if they can get the accuracy up. Some people actually kind of argue with data scientists because a data scientist can't always explain why the model works, but they can show that it does work, which is kind of, you know, if you think about science, we're always coming up with principles to say why bees pollinate in this way, why seasons have this effect on the weather. But with data science, you know, we're throwing in some numbers and we're getting 70% accuracy, right? So that's quite appealing to some people. So there are kind of, I can't really say how many different fields of machine learning and AI there are, but NLP is a special one. That's what we've been doing, natural language processing. There's also stuff like natural language understanding and argument mining. These are all to do with language, figuring out meaning, figuring out patterns in language. So there's lots of really cool stuff with that. You've got stuff which is purely numbers, predicting stock prices, predicting stuff like how much your company following might grow on social media. And then you've got also stuff like, excuse me, DNA sequencing. You can find patterns in DNA, and you can use that for healthcare and pharmaceutical research. So I think another thing maybe that would help people is talking about machine learning versus deep learning. So again, I kind of explained at the beginning, it's not clear where the one starts and the other ends, but I'd say if you're using a neural network, it's probably deep learning. And deep learning, you don't always want to use it, right? It's much better to try out a simple model, see what it says, and then go back to the data. Can you clean the data better? Can you balance your classes better? Can you, you know, filter out stop words or maybe keep stop words? And then you figure out, okay, I could use a deep learning model. And that is the stuff the state-of-the-art companies are using. So yeah, that is pretty much all I have to say on that topic. So again, any questions, anything to follow up on?
I don't know if you said that earlier in the introduction, but I was wondering how you got into data science, if you got like also a physical or mathematical background, or how did you, yeah, get into it?
So I'm pretty much, it started off as a hobby. So I'm a data scientist now, but basically like I just did a bit of programming and I was like, machine learning is so cool that I want to get good at it. So then I just did like online tutorials, projects like this. And then, yeah, so I'm starting at Roche as a data scientist and will be completing a degree in data science. But that's about as far as my background goes. I'm pretty much just a hobbyist turned professional. I'm not a professional just yet, but we'll be starting.
Okay, so you're not working in data science at the moment, but you're...
No, yeah, so I have been working. Certainly in terms of career, I'm pretty much at the beginning of the career.
Okay. Cool.
Cool, and I hope that turns a few people down a similar path, if that is of interest.
May I ask something about a library or framework? There is a meetup here in Birmingham and they talk about it a lot. So I just want to hear your input. You just mentioned something about this. Don't rush to go into deep learning too fast. What do you think about fast AI, the fast AI stuff? Have you heard of it?
Yeah, I have heard of it. So I haven't really used it much, but it's really good, right? Like that's certainly what I think most companies who are really using data scientists are using fast AI.
Okay, thank you.
Just, you know, as a set of tutorials really, and as a set of tools. So yeah, check out Fast AI. I'll send some links. That's a really good idea, actually. Basically what Fast AI is, it's kind of similar format to this. It's kind of a bunch of tutorials, but it gets a bit more hands-on and there's so much of it. So you can kind of pick and choose parts that interest you the most. So yeah, really good idea. Thank you for that. I will send out some Fast AI resources. It's totally free as well. That's just one more thing I want to add. Like, okay, there are many Udemy courses that are worth paying like £10 for, but just be careful. There are a ton of people out there that are charging, you know, exorbitant fees for effectively stuff that you can get for free very easily. You don't really need to spend a cent on data science education at this point, besides obviously like a degree or something. But yeah, another thing to add, and I'll send links on this. If you're interested in learning the maths, but you don't want to get too involved because possibly you don't have the foundations just yet, Andrew NG's machine learning course on Coursera. He's really good at explaining the maths behind stuff like what we're doing, linear regression, logistic regression. He makes it very intuitive and understandable. And ultimately, that's very useful for when you're speaking about the model to say, supervisor, you could talk a bit about the maths, but use language that's clear and is not jargon, right? Okay, that's all it from me. I'll just leave 1 or 2 more minutes. If anyone has anything that's popped into their mind, we will do that. But if not, I will wish you all a good night and all the best for your data science careers or hobbies.
Thank you so much.
Thank you very much.
Thank you.
Thank you very much for doing this.
No worries.
Thanks, Finn. It was great. Cheers.
No worries. I'm
Really enjoyed
very
that.
happy to be of help. Thank you.
Thank you.
All the best.